Welcome to SS2 Technical Drawing, Term 3, Week 2. Today we study mechanical engineering drawings, the drawings used to design, manufacture, and maintain mechanical parts and machines. Mechanical engineering drawings are the language of manufacturing. Every bolt, gear, shaft, bearing, bracket, and housing starts as a drawing on paper or a computer screen. The drawing specifies the shape, size, material, surface finish, and tolerances of the part. Without mechanical engineering drawings, modern manufacturing would be impossible. In Nigeria, mechanical engineering drawings are used in automobile workshops, in manufacturing companies such as Innoson Vehicle Manufacturing in Nui, in the petroleum industry, in the construction of bridges and structures, and in all maintenance workshops. Mechanical engineering drawings follow standards set by national and international bodies. In Nigeria and across the British Commonwealth, the British Standards Institution Standard BS 8888, Technical Product Documentation, is followed. Internationally, the ISO standards, particularly ISO 128 for line types and ISO 1101 for geometric tolerances, are the reference. In American practice, the ASME Y14.5 standard is used. All of these standards specify the same fundamental elements: line types, projection methods, dimensioning, tolerancing, surface finish symbols, and title block content. The two projection methods used in mechanical drawing are first angle projection, the standard in Nigeria and Europe, and third angle projection, the standard in the United States. In first angle projection, the object is placed between the observer and the projection plane. The front view is the starting view, and all other views are placed on the opposite side from where they would be seen. In third angle projection, the projection plane is between the observer and the object. In Nigeria, WAEC and NECO examinations use first angle projection, so every student must master this system. The projection symbol, two overlapping circles or cones, must be drawn on every mechanical drawing to indicate which projection system is used. Mechanical drawings use specific line types to convey different types of information. The continuous thick line, the most prominent line on a drawing, represents visible outlines, the actual edges and surfaces of the part that can be seen in that view. The continuous thin line is used for dimension lines, projection lines, leader lines, hatching lines, and fold lines. The dashed thin line represents hidden detail, edges and surfaces that exist but cannot be seen in that view, because they are behind or inside the visible surfaces. The chain line, alternating long and short dashes, is the center line. Center lines are used to mark the axes of circles, cylinders, cones, and any feature with rotational symmetry. Center lines are also used to indicate lines of symmetry. The chain thick line, with an additional short thick dash at each end, marks the cutting plane for section views. The dot line indicates a pitch circle diameter for gears. These line types are defined in BS 8888 and ISO 128 and must be used consistently on all professional mechanical drawings. Dimensioning is the process of adding sizes and measurements to a drawing so that a machinist or manufacturer can make the part to the correct size. Dimensioning follows strict rules. Rule 1. Every dimension needed to manufacture the part must be shown, not more, not fewer. Redundant dimensions can confuse the machinist and lead to manufacturing errors. Rule 2. Dimension lines are thin continuous lines with arrowheads at each end, placed outside the outline of the part wherever possible. The arrowhead touches the projection line, which is a thin line extending from the edge of the feature. Rule 3. Dimensions are written above the dimension line for horizontal dimensions and to the left of the dimension line for vertical dimensions, reading from the bottom of the sheet. Rule 4. Circles and arcs are dimensioned by their diameter, using the symbol O, or radius, using the symbol R. For example, O50 means a diameter of 50 mm, R25 means a radius of 25 mm. Rule 5. Holes are dimensioned by their diameter. A hole through the part is shown with a note such as O20 THRO, meaning 20 mm diameter through the full thickness. Rule 6. Angular dimensions are given in degrees. Rule 7. All dimensions must be given in a consistent unit. For engineering drawings in Nigeria, the unit is millimeters, and the word mm is omitted from individual dimensions but stated once in the title block as all dimensions in millimeters. Two important concepts in mechanical drawing are surface finish and tolerances. Surface finish is how smooth or rough the surface of a part must be. In a rough casting, the surface is irregular with peaks and valleys. A machined surface is smoother. A ground surface is very smooth. A polished or lapped surface is extremely smooth. Surface finish is specified using the roughness symbol, a stylized check mark, with a number indicating the maximum roughness in micrometers. RA 12.5 means the surface must be no rougher than 12.5 micrometers roughness average. This is the roughness of a typical machined surface. RA 0.8 means a finely machined or ground surface. Tolerance is the allowable variation in a dimension. No manufacturing process can produce a part to an exact size, so we specify the maximum and minimum acceptable sizes. A shaft diameter specified as 50 plus 0.0 minus 0.02 means the shaft can be anywhere from 50.00 mm to 49.98 mm. The tolerance is 0.02 mm. Tolerances are critical for interchangeable parts, parts that can be replaced without fitting, which is the basis of mass production. In Nigeria, tight tolerance manufacturing is carried out in the petroleum industry, where engine components and pump parts must be made to precise dimensions. To summarize, mechanical engineering drawings are the universal language of manufacturing. They follow standards, BS 8888 in Nigeria and Europe, ISO 128 for lines. The projection system used in Nigeria is first angle projection. Always mark the projection symbol on your drawing. Line types carry specific meanings: thick continuous for visible outlines, dash for hidden detail, chain for center lines, chain thick for cutting planes. Dimensioning must be complete, no redundant dimensions, clear, and consistent, all dimensions in millimeters, circles as diameter, O, arcs as radius, R. Surface finish is specified with the roughness symbol and array value. Tolerances specify the allowable variation from the nominal dimension, essential for interchangeable parts manufacture. For WAEC, practice drawing detailed drawings of simple components, a shaft, a bush, a bracket, a flange, with correct line types, complete dimensioning, and proper title blocks.